Well, I really wanted to do a building construction segment, and we are going to start with the 5 types of building construction. So our building classifications, also known as the 5 types, here they are. We have type 1, which is fire resistive, type 2, non-combustible, type 3, which is ordinary construction, type 4, heavy timber, and type 5, wood frame construction. Now I'm going to show a quote here from James Johnson, which states, the 5 types, they are good for education and maybe not so good for size up. And again, this is from James Johnson. He's a firefighter with Vancouver Fire Rescue Services. Let's start with type 1, fire resistive construction. And to me, the key word here is fire resistive. So all structural members are made of non-combustible materials, and this normally includes concrete and steel. So reinforced concrete combines the compressive strength of concrete with the tensile strength of steel. And I've got the year 1933 in brackets here because this is when some of the building codes changed, and they changed due to an earthquake that happened in the California area, which had major destruction. The engineers of that time period figured out that material like reinforced concrete would stand up better to the threats of earthquake, which would result in less destruction of buildings. So just to review, compressive strength is equal to resisting loads placed on the structure, or essentially pushing forces, where the tensile strength of steel takes up the tensile forces or pulling forces preventing the concrete from cracking. Now, reinforced concrete provides thermal protection to the steel. And it's important to understand that the steel must be protected to be considered fire resistive. So even in this picture where you can see structural steel columns and beams, they have a fire resistive spray on them. Again, ways that we can protect the steel. We've talked about reinforced concrete. You could also use gypsum board, or again, like in this picture, fire resistive spray. Here's another picture of a parallel cord metal truss with the fire resistive spray with corrugated or Q decking, sheathing on top, again sprayed with the fire resistive spray to make it a type 1 fire resistive building. Here's a picture of gypsum board covering protecting the steel column. And this video is just showing concrete being poured over the steel rebar to protect it. Some examples of type 1 building construction. In the top left is an airport. Bottom left, some schools would be type 1. I've also seen some schools fall into type 2 category. Hospitals are usually type 1. And the most common that I run into is the picture on the right here, which is a high-rise building. Now, some pros to type 1 building construction. It is the most resistive to fire and collapse. Type 1 building construction is supposed to have a fire resistive rating of up to 4 hours. This allows time for evacuation and fire control. And again, a lot of these type 1 buildings are large buildings, so there could be a lot of occupants in it, whether it's a residential high-rise or even if you think of a hospital, there's a potential for a lot of occupants in these buildings. A lot of times there'll just be localized failures from fire, which could be concrete spalling, or it could be an I-beam which essentially has lost its fire rating and has started to sag. Now, some cons of type 1 building construction could be the building height itself. So the building now becomes the obstacle. This picture on the right, this is just my crew. We're out doing some training and we've tested this. It really depends how close we can get our aerial device to the building, which would dictate what floor that we can reach with our aerial when it's fully extended. Obviously, the further our truck is away from the building, we won't be able to reach as high with it. Again, if I'm relating this to a high-rise residential building, we're going to be evacuating a large number of occupants. Also have to worry about smoke migration, which could migrate through stairwells, elevator shafts, and even HVAC ductwork system. And really our primary fire hazard that we're concerned about is the contents within the building, because essentially this is a reinforced concrete building, just a big concrete box with a bunch of little boxes inside. Moving on to type 2, non-combustible construction. So type 2 is similar to type 1 as it uses non-combustible materials. However, the steel structural components and roof system are unprotected. So this picture on the left, you can see we've got corrugated metal or Q decking, again with our open web parallel cord truss with unprotected steel, versus the picture on the right, which we've already seen, which has the fire resistive spray protecting it, which makes it a type 1. So some examples of type 2 buildings include big box stores. So on the top left, we have a Walmart, and the top right, we have the Home Depot. And next time you go into one of these stores, just look up and you will see unprotected structural steel in the roof system. The bottom left picture is large commercial or industrial buildings are usually type 2, and a lot of times strip malls are type 2 building construction. So a type 2 building construction hazard. The primary hazard to the unprotected steel is the contents and how close it is to the steel. So even in this picture, which is some sort of storage warehouse, if you think a fire starts in this building and it spreads to all the products on that top shelf and they catch on fire, now that fire is very close to that unprotected steel. And if you didn't know, type 2 building construction, unfortunately, is the least resistance to collapse when exposed to fire, which is the opposite of the type 1, which is the most resistant to collapse. So why is type 2 the least resistant to collapse? Because when heated to approximately 593 degrees Celsius, the structural steel will lose half of its strength. And unfortunately, it can start to twist and sag, which could equal it dropping its load. So again, when I think of a building even like in this picture, which would be a large industrial building, if you've got rooftop units or HVAC units on the roof, and my structural steel has now lost half of its strength, those rooftop units or HVAC units could come through the roof onto us. Now, on a 100-foot I-beam, evenly heated to approximately 540 degrees Celsius, can expand up to 9.5 inches lengthwise. This, unfortunately, could push down columns or walls of the building, which again would equal collapse. Now, when steel cools to its original temperature, it contracts back to its original length, but could stay in a distorted form. So what are some firefighter tactics that we can use in type 2 buildings? Use your thermal imaging camera to read your ceiling temperatures. Because again, just a reminder, at 590 degrees Celsius, the structural steel will lose half of its strength. And then let's use hose streams to cool that steel before we get to these temperatures where it could lose half of its strength. And again, keep in mind that when steel cools, it will contract back to its original length. Moving on to type 3 ordinary construction. Our exterior load-bearing walls are constructed with non-combustible material, which could be concrete block, which you can see on the Bravo side of the building on the right, or it could be brick, as you can see on this building on the left. The interior is constructed with combustible wood components, and this would include the walls, the floors, and the ceilings. Now your type 3 exterior walls, this is a picture from Bobby Eckert's class of Building Construction for Idiots, and he describes the type 3 exterior walls, because again, these are structural walls. He relates them to a pizza oven, where a pizza oven would cook hundreds and hundreds of pizza, but maintains its structural strength. So type 3 examples, we can see we have a residential house on the left. On the top right is what some people refer to as Main Street USA. I believe in New York they might call these taxpayers, where essentially you've got commercial occupancy on the ground floor, and then your second and third levels could be residential apartments. And then you can also find your type 3 in low-rise buildings, which I know I've got a few of these in my first run area. Some type 3 hazards is your combustible interior structural components and the contents within the building. Again, your structural walls will stand up well to fires. Extension of fire and byproducts, a lot of times this is going to happen vertically and in void spaces. So for example, caulk lofts and attics. Type 3 construction also could have, again, this is more in Main Street USA, could have some parapet walls and some cornices, and I'll explain those coming up. So just so we understand the difference between an attic or a caulk loft, a lot of times attics are much bigger than caulk lofts. Some people actually convert them into living spaces, whereas a caulk loft is a much smaller area and you wouldn't be able to convert that to a living space just due to its small size. A parapet wall. It is a continuation of a wall above the roof line. And I just want to make note that, like most things that age, sometimes the building materials will age themselves, and it could leave the parapet weak and has potential for collapse. I've also heard that some of these parapets might be built on a steel lintel. And again, if that steel was exposed to heat, it could twist, which again would pose a collapse hazard at a fire scene, something that we should keep in mind as firefighters. And a lot of times you'll see these parapet walls on the alpha side of the building. This picture is just showing that if you had your aerial up to a building with a parapet, you might need a ladder to get onto the roof over the parapet. But my point is just please don't rest your ground ladder on the parapet, as again, we can't determine its structural stability just from looking at it. There are other options, and here's two of them. If you are going to do this, just run your ground ladder off of your aerial device. Cornices. These are decorative moldings found on buildings. They do pose, again, a collapse hazard at fire scenes. And keep in mind that these are not designed to support the weight of personnel or ladders. You might find yourself wanting to use one as a foothold, but just bear in mind it's not designed to hold our weight. The other issue with cornices are, depending on how they are built, there could be a void space in them, and again, fire could travel through them. Next, and I just want to see if you're paying attention here. We just covered type 3. I'm moving on to type 5. Yes, I'm skipping type 4. I'm going to come back to it. So type 5, wood frame construction. All structural members will burn. This includes your walls, floor, and roof are all constructed of flammable wood. And sometimes you will have a combustible exterior, as seen in this picture, which would be a vinyl siding. Here's some type 5 examples. And again, you will notice these are all residential. I just want to point out some different building styles here. The picture on the top left, that's known as a backsplit house. So this main level on the alpha side would just be a single level. And as you walk towards the Charlie side of this house, you would find a set of stairs. You'd have approximately 6 stairs going up to the second floor, and you'd probably have 6 stairs going down to the lower level. So that is called a backsplit house. Very similar to the backsplit, this picture in the top middle, we have a side split house. So again, you can see this portion of the house on the right is just a single level. And as you walk towards the Bravo side of this building, you would find stairs that lead, again, approximately 6 stairs that might lead up to the second level and 6 stairs down that might lead down to the lower level. And just a reminder, if you were looking for extension, fire extension, in either of these in the attic spaces, you would have to check both attics, as these would have 2 separate attics. The picture on the right here, that's a typical single-story bungalow. The picture on the bottom left, those are your typical townhouses or row houses, depending on your terminology. And then this picture on the bottom right, this is the bread and butter in my first run area. We call these raised bungalows. You can probably see it a little bit better on the neighboring house here, how that basement would be partially above ground and partially below ground, hence the term a raised bungalow. Technically, there is 2 levels, just part of the bottom level would be underground. And with this picture, I really just want to make sure people understand some different terminologies here. I responded to a fire at a house very similar to this one once, where the first-in captain's initial report sounded something like this. It said, "Dispatch, pump 1 has arrived at 123 Anywhere Street. I have a single-story detached house with flames visible from the second floor." And hopefully if you were listening to what I just said, you could see how confusing that initial report was when he said it was a single-story house with flames visible on the second floor. So I just want to point out that this style of windows that are essentially projected out from the roof line, those are called dormers. And I also want to point out that normally when you have windows above the roof line, and I'm going to say this is specific to gable roofs. When you have windows above the roof line, we call those a story and a half. This is a house that I used to live in. Again, I'm just pointing out, first it's a gable roof, and I have a window above the roof line. So if I was the first-in officer, I'm going to describe this house as a story and a half. And why do we call it a half story? Because when you went up to the interior of the second floor, you would notice that the ceilings are slanted. They are following the roof line. And a lot of times when you see this, you are going to have knee walls. If you weren't sure what a knee wall was, and again, you would see in the story and a half, you'd have the slanted roofs. The knee walls with the straight wall down creates a void space. Now, even for myself, in this house, we could use, they put access doors on those for storage, so we could store stuff in here. But again, as firefighters, what's really important for us is that this is a void space where fire could be hiding. And again, this picture is just showing, also pointing out, you could have dormers that are above, again, windows, whether it's a dormer or a regular window, above the roof line is indicating a 1.5-story house. Now, you could also have a 1.5-story house with a bump out. So even the current house I live in, from the front, it appears to be a 1.5 stories because I've got 2 dormers at the front of my house above the roof line. But if you walked around to the Charlie side of my house, this is what you would see. Again, you would essentially have 2 separate roof lines. So you can see you have a roof line here and then the bump out roof line here. So to me, when I see a bump out, again, this would be on the Charlie side of the house, that's probably an true 2-story house when it has a bump out like that. So just something to keep in mind when you're doing your 360s. Here's another interesting dormer. This is in an area just north of my first run area where you can see, hopefully this picture shows it well, the windows on the first floor, the second floor. Hopefully you can see some reflections from the sun in this picture. And then if you look at the dormers that are above the roof line, you do not see the same reflection because there is no living space here. These dormers are just for decorations. So again, it's important to understand and to know your first run area and what you may or may not be up against. But if somebody tried to ladder up to these dormers and jump in here, they'd probably be jumping into an attic space, not a living space. Let's check out some wood frame construction types because construction has changed over the years. So on the left, we can see it's a balloon frame. And if you don't know what a balloon frame construction is, essentially they used to have studs that ran all the way from the basement and they would run continuously all the way up to your attic space. And there'd be no fire stops. It was just a straight void space from the basement all the way up to the attic and potentially also into the attic. So the fire, you just think again of that void space, and we know fire and smoke can move vertically. So unfortunately with balloon frame, you would get some rapid fire spread throughout the house. Another type of construction is platform construction. So that's when your studs would just run the single length of the floor, and then you'd have a platform to build up your second floor, and essentially you have a fire stop between the first floor and the second floor. So this would result in less fire spread throughout the house. And just so you know, platform construction is now the most common type of wood frame construction used today. This picture floats around the internet, and it's interesting to see that you see both types of construction in this building, where you've got a balloon frame on the left, where again, you can see this wall stud or column is going to run continuously. And you've got a void space here where fire could travel. And then you could see how these wall studs have a platform sitting on top of them. And this would act as a fire stop. Here's a nice exterior picture of balloon frame. So again, we've got studs that run all the way, if there's a basement, and in this picture it's the ground, all the way up to the roof. And you can almost see how the fire would have traveled straight up here. So it starts low and it just moves up and up all the way through the void spaces. So let this sink in. There are more single-family dwellings than any other building type. And Type 5 construction is responsible for the majority of deaths and injuries to firefighters and civilians. And I got this statistics from the Art of Reading Buildings book. So the reason I leave Type 4 out is because a lot of times people get confused between a Type 3 and a Type 5. Because, I mean, in these pictures, these are both residential houses. So how can you tell the difference? They're both brick. How do I know which one's Type 3 and which one's Type 5? And the answer comes from reading brick patterns. So I'm just going to give you a moment to look at these 2 brick patterns, and I don't care about the color, but what do you notice the difference between these 2 brick patterns? Hopefully you notice this one on the right has a slightly different brick pattern, which is known as a header course. So if we point out bricks here, this side of the brick is known as the header, and then this long side of the brick, so bricks are a rectangular shape, is known as a stretcher. So that's why they call this the header course. Our Type 5 brick pattern, it is just a single stack of bricks. And it's important that you understand it only supports its own weight. It's essentially just a brick veneer that covers the building. It is not structural brick. And on our type 3 construction, you can see that this is not just a single layer, it is structural brick. It can hold more than its own weight. So going back to our brick veneer or facade, facade will have some weep holes in it sometimes. So bricks and mortar are porous and absorb water. Water runs down the backside of the bricks between the facade and the framing wall. Weep holes allow the water to escape. Now, I also want you to understand that weep holes are not always present, but if they are present, it indicates a facade or a brick veneer. Okay, now I'm coming back to type 4, heavy timber construction. This can consist of exterior masonry walls that surround heavy timber. So your load-bearing walls, and this is important to remember, your load-bearing walls have a fire resistance rating of 2 hours or greater, so a minimum of 2 hours. And I want you to remember that coming up. There is not supposed to be concealed spaces in these buildings. If there is, it's because somebody has done a renovation in the building. And you normally find these in older buildings. And I try to ask people, why do you think we don't see a lot of type 4 heavy timber construction anymore? And the answer is because it's no longer cost effective. So some type 4 examples, you can see on the top left, a lot of old industrial buildings would have the non-combustible exterior masonry, and the interior would have these big mass timber beams, which you can see on the right. And this is very common in the city that I work in, where these old industrial buildings have been converted into apartments or lofts. On the bottom left and middle, you can see log cabins are an example of type 4 construction, and a lot of old churches also use type 4 construction. So again, we have this question, how do you tell the difference between a type 4 and type 5? Because again, both these pictures look like log cabins, but how do I know which one's which? And hopefully you picked out that picture on the left is much smaller logs. Because if you remember, type 4 buildings have to have a minimum of a 2-hour fire resistance rating. These smaller logs probably don't have the minimum 2-hour fire resistance rating, which a much larger log with more service area would give you the minimum 2-hour fire rating. So some type 4 hazards that we could come across. These are fast-moving fires due to the big open spaces within these buildings. There's a potential that's a lot of old, dry wood, which would mean a large fire load for us. I want you to remember, if you're incident commander, large fires, you're going to need big water. So water supplies needs to be one of your first considerations. And then think about collapse considerations. Sometimes when the roof goes in, your walls could go out. Consider that when you're parking your apparatus near these buildings. So type 4 collapse hazards. Type 4 is actually the second best construction type for resistance to collapse. In most cases, firefighting operations would have switched to defensive before the danger of collapse. The volume of fire required to burn through the structural members would drive firefighters out of the building. And even in this video, you can see a lot of these solid, heavy timber structures that made up the roof, they are still standing, even though the sheathing might have failed. And I just added mass timber in here. So again, we don't see a lot of heavy timber nowadays, but you will start to see mass timber. So the difference between heavy timber and mass timber uses large engineered wood products. The engineered wood is very strong and durable. Mass timber is also eco-friendly with lower carbon footprint, and the wood actually stores carbon. The building code changed in 2025 to allow up to 18 stories in Ontario, Canada. This was increased from 12 stories, which was previously increased from 6 stories. So again, you can see how building codes have changed. Okay, I'm going to need a little bit extra here. So type 6, which is, I want you to understand, type 6 is not a real building construction type, but hybrid construction is real. So hybrid construction combines structural elements from more than one of the traditional 5 types. So why is hybrid construction becoming more popular? And again, I'm going to steal this from James Johnson, but he describes this as building codes used to be prescriptive, meaning you had to use, as an engineer, you had to use a specific material. However, building codes have changed and they are now more objective based, meaning they focus on desired outcomes as opposed to the specific materials. So this allows your designers and engineers to propose alternative approaches to design, as long as they can prove equivalent objective and fire performance. So keep this in mind as firefighters, that they still have to prove equivalent fire performance. And one example that I can think of a hybrid building construction is podium construction. And again, this is becoming more common. So podium construction includes a heavy non-combustible base, which is the podium, and several stories of lighter frame construction above, so more wood frame construction. This is common in newer mixed occupancies where the ground floor might be used for retail or for parking with residential on top. The last type I want to go over, which is type 7, and this is really anything people can find to make buildings out of. So on the top left, you can see a converted bus, and it's like, what type of construction does that fall into? Lots of shipping container buildings now. Encampments is probably the biggest one that I've encountered, because again, people use anything and everything they can find. And the bottom right is just an example of something somebody created out of wood pallets. So you can use the 5 types as a benchmark, but just remember, not every building fits perfectly into the 5 types anymore. And I just wanted to cite my sources of The Art of Reading Buildings and the Fire Officer's Handbook of Tactics.